Hi everybody, and welcome to the course Computers and Computations. My name is Dr. Neil Barton. I'll be taking you through this course. Now, this course covers some themes I've become increasingly more interested in recently, especially concerning the idea of whether or not computers might be limited in any kind of sense. So I hope you enjoy the course. There's not too much to cover this week. We'll just be going through an outline of the course and explaining some things that we will be covering, some things that we won't be covering. So I hope you're looking forward to it, and here we go. Okay, so here we go. Not too much to go over this week. We'll just go through the course outline, and I'll mention some things that we will cover, but also some things that we're not going to cover in the context of the course. Great, so let's start with some motivations for why consider the notion of computation and why consider this idea of what a computer, something that implements a computation, might be. So, let's note that this video itself is being recorded right now, and you are probably playing it on a computing device of some sort of machine that, given a bunch of inputs, can yield particular outputs. So given the input of my voice telling you this now, this can be then codified somehow into the memory of the computer and then replayed at a later date. And this goes throughout our contemporary life. So computers and the computations they implement are incredibly pervasive. So something that we've seen in recent times has been a huge number of tasks have been automated by devices that use at their heart some sort of computational procedure, some sort of computational device implementing that procedure. So a question we might have at this point is, look, is there anything that computers can't do? Are computers in any way limited? You might think, given the enormous success of automation and so forth, the enormous success of information transfer given computers, that actually the limits of computers are boundless. Computers can do pretty much anything. So this, in some sense, is going to be the main question to which we address this course in light of the seeming ability of computers to perform almost any task, and that's, what are the limits on computations? Are there any limits? And if there are limitations, what implications do these limitations have? So in analysing this question, we're going to explore several topics. So we're going to be looking at how computation developed throughout history, across cultures and so forth, how computers might be able or unable to represent certain kinds of effective procedure, so certain kinds of things we can carry out, how computers might or might not be able to represent the human mind, and if there are challenges there, and what kinds of time and space constraints there are on computations. And then once we've gone through some of these ideas, which we'll do in a lot more detail in future weeks, we'll also be talking about certain implications, both for the nature of computation itself, but also I think there's possibly some links between these kinds of questions and issues concerning things like ethical responsibility. And so here's exactly how we'll do this. So week 1, which you're listening to right now, we've just given an introduction, outline of the course, and next week we'll be talking about historical accounts of computation. Then in weeks 3 to 5, we'll be looking at some kind of technical results, some of the mathematics behind the work of people like Turing in providing a mathematical analysis of computation, and given this mathematical analysis, what kinds of limits there are. Once we've done that, we'll look at the Church-Turing thesis. This is the idea that effective procedures are exactly coextensive with Turing computations. And then in weeks 7 and 8, we'll look at some questions concerning whether or not the human mind can be represented by a Turing computer or a Turing machine, and in particular the results from weeks 4 to 6 have, what other implications that those results have for the question of whether the human mind can be represented by a Turing machine. Then we'll have the Christmas break between the 24th of December and the 6th of January. And then after that, we'll start looking at some more recent questions in theoretical computer science and what the implications might be for philosophy. So we'll look at computational complexity. This is a kind of area of theoretical computer science where we look at time and space restrictions, whether those have implications for philosophy. We'll, in the next week, look at quantum computation and whether or not that has any implications and what the potential payoffs of quantum computers might be. And then after we've done this, we'll try and bring things together on some more philosophical issues again in the final 3 weeks, starting off with looking at the ethical implications of some of the results, or whether there is a question of responsibility given some of the difficulties we'll have seen in weeks, the earlier weeks. And then in the last 2 weeks, we'll look at whether or not notions of computation help us isolate the standard model of arithmetic. And finally, in the final week, we'll look at if there's a decent distinction can be drawn between digital and analog computation. Now, given the course outline I've just presented, I thought I should mention some things. Well, one particular thing we won't cover. There's plenty that the course can't cover. Work on computation is pretty broad. But something in particular that we're not going to cover, especially where the focus of the course is limitations of computation, is debates concerning artificial intelligence. So eagle-eyed viewers might have thought to themselves, well, this is one of the places where philosophers and theoretical computer scientists get very excited. To what extent can artificial intelligence mimic various kinds of procedure, in particular more human procedures and perhaps even consciousness? So while we will look at some arguments that the mind cannot be represented by a Turing machine, we'll especially consider the Lucas-Penrose argument here. I'm not going to go too deeply into debate surrounding artificial intelligence, what it can accomplish, and cognate questions such as those surrounding the Turing test. Now, the main reason here is that I want to focus on the specific nature of computation rather than, say, artificial intelligence, as it can be formalized, and the things we can prove about such formalizations of computation and what this can tell us about philosophy. And I think the situation in AI, while absolutely fascinating, it's not so clear how to formally define what an artificially intelligent machine is. But there's a second reason, which is that we already have a really fantastic course at Konstanz on AI. It's going to be run by Dr. Diego Fresinelli and Dr. Caterina Moruzzi. It's called Cutting Edge Debates in Artificial Intelligence, and they'll cover a lot of these topics. And I strongly encourage people to attend that course, audit it. It looks like it's going to be very interesting. I'll be attending myself. So that's why I'm not considering AI, but I think the debates are super, super interesting, and we will see some contact points throughout the course, occasionally with issues in artificial intelligence. Okay, so just a little bit about the style of the course. First up, this is a course intended, or the level is pitched at master's students and advanced undergraduates. And for this reason, it's not going to be just the kind of teaching course where we take things very slowly. I'll also be exploring some themes that might arise in research and some things that I've been thinking about developing in my own research. So for this reason, this material is going to be pretty hard, especially in the second half of the course. It's going to get quite technical at points. But I want to emphasize that this shouldn't put you off. Philosophy, logic, and mathematics at the research level, these are meant to be hard. That's part of why we do it. That's part of what makes it fun. And I encourage anybody to look at the course and enjoy it and see if you have your own ideas about what you think the different parts of the course tell you about the nature of computation. It certainly shouldn't put you off too much if the material is hard. Of course, it's going to be hard. Okay, so a second thing about the style of the course. So this is very much a philosophy course and not a mathematics or theoretical computer science course. That said, when you're discussing the nature of computers and computations and the kinds of limitations there might be, we're just going to have to get into formalization and discussion of mathematical results. Now, whilst we will include some formal definitions and we will talk about some proofs and go through some proofs, our main objective isn't to just churn out proofs on the blackboard, let's say. Our focus is going to be rather on getting to grips with how the relevant results mesh with philosophical considerations. So this is going to be especially visible towards the end of the course, where we'll deal with some difficult topics, computational complexity theory and quantum computation especially. These are topics that you could give a whole course on their own. A whole semester could be spent studying these. They're absolutely mathematically fascinating as well as philosophically fascinating, but it does mean that we won't be able to go into real heavy mathematical detail on those particular topics. Now, this doesn't mean that the mathematical detail in the background is in any way uninteresting or irrelevant, and on the contrary, I think to get a really deep understanding of these topics, it's well, if not necessary, then very, very useful to immerse yourself in the mathematics too. And I strongly encourage anybody listening or any of my students to really give it a go at getting to grips with some of the mathematics here. I think it pays dividends in really understanding how the relevant kinds of computation work. But from my perspective, my main focus is really to provide a kind of intuitive roadmap around this quite difficult route through the formalism and give you the tools to explore some of the philosophical ideas on your own. Okay, so that was the rough course outline. Next week in week 2, we'll be looking at some of the early history of computation and how ideas of computation developed across different cultures throughout the world, and some of the main figures here. So people like Lovelace, Babbage, and Leibniz that occurred in the history pre-Turing. I guess we'll be looking a little bit at the extent to which these figures presented some ideas that were ahead of their time in some sense. Now, apart from these historical questions being very interesting in themselves, this is going to lay some of the conceptual framework for the technical setup in the following weeks. So I look forward to seeing everybody next week. And I hope you're looking forward as much as I am to going through some of this material with me. All right. See everybody soon.